Hi, my dear. Uncle Jimmy. Here I am. My dears, continually chapter 12, water logging and field drainage. Really, we'll divide this chapter for 3 parts for simplify, such as Part A, water logging phenomena, surface drainage and open drainage. Part B, subsurface drainage. And Part C, vertical drainage, bio drainage and references. Let us see together. My dears, Part A. Generally, when soil productivity is affected by high water table is known as water loss. Sometimes the around conditions are not suitable and consequently water table rises to a critical depth, wherever starting on rising to the soil surface by capillary, hence causing an accumulation of harmful salts in the surface soil layer, as shown in the enclosed figure. Figure showing water logging feature. Causes of water logging phenomena. Water logging is caused when input water quantity exceeds the output water components in soil, which is meaning in another word, occurred a positive water balance in the soil profile. The main factors which affect on rising groundwater level and causing soil water logging can be summarized as remember in front of you, my dear. Follow it, it is so easy and clear. Effects of water logging on environmental conditions. Look, my dear, there are many harmful effects of water logging phenomena on the environmental conditions as shown in front of you. Take in consideration that there are many observations which can be noticed for detect the problem of water logging before occurring as shown. Follow it, my dear, by yourself. It is so easy and clear. Water logging and salinity control. Really, water logging and salinity problem should be seen as twin problems. Accordingly, the main aim of preventative or measuring this phenomena is to keep both the water and salt balances are negatively while keeping the air-water balance at an optimum desired conditions, as shown in the enclosed figure. Figure showing the effect of water logging on soil salinity and deterioration. Drainage history. The term land drainage or agricultural drainage refers to the artificial disposal of excess water from agricultural lands, including its contents of soluble salts, to enhance soil fertility. It is an ancient term, but really was less important than irrigation in the olden times. Advance of field drainage methods. Really, the installation of drainage system will achieve good hydrological conditions, and consequently, many advances can be achieved in the agricultural land, as shown in front of you, my dear, to see important points. Generally, there are different methods of agricultural field drainage such as surface drainage, open drainage, subsurface drainage, well or vertical drainage, and bio drainage. Surface drainage method. Really, it is the oldest and most economical method, which consists of shallow surface ditches for disposal of the excessive surface water as a result of excess rainfall, runoff, seepage, and or overflow from streams. Accordingly, these types of shallow ditches can't remove the subsurface water in soluble file, which requiring another method of drainage which will be explained after. There are different systems of surface drainage such as random ditches, bedding system, field ditches, surface open ditches, and cross-slope ditches system. Random ditches system. Really, this is a suitable system for drainage of puddle areas, as ditches should be installed at random trends, depending on the scattered random distribution of ponds, in addition to achieving minimum cut and less interference and farming operations, as shown in the enclosed figure. Number 2. Bedding system. Really, it consists of narrow wet plough lands in which the dead furrows run parallel to the prevailing land slope. The area between each two adjacent dead furrows is known as a bed, as shown in the enclosed figure. Table showing comparison between different systems of surface drainage methods. Number 3. Field ditches system. It is similar to bedding system, except that the drains are spacing on not equal further apart while having more capacity than dead furrows, as shown in front of you. Number 4. Open ditches system. It is similar to the field ditches system, except that ditches here have an equally apart, deeper, and hence can't be crossed by most of farm machinery, as shown in the enclosed figure. Number 5. Cross-slope ditches system. It is similar to contour strip terraces and adapted to soils having slow permeability, where tilling is so difficult and not practicable, slope of 4% or less, and containing numerous shallow depressions, as shown in the enclosed figure. Open drainage method. Really, it is a net of deep open ditches, assessing for disposal the excess water from the plant root zone, hence play an essential role on lowering the water table level, and consequently alleviates its harmful effects on water logging phenomena and crop production, as shown in the enclosed figure. Preliminary survey studies. Really, it is an initial study which are necessary for investigation any proposal project carried out in sufficient detail for achieving a good suitable design with relation to the valid economic feasibility of plan. Hence, these studies should be including many variables as shown in front of you, my dear. Follow it by yourself, it is so important. Design of open drains. A proper design is necessary for achieving an adequate drainage at reasonable cost and several aspects. Salinity diagram. Selection and the gradual grades of open drains depend mainly on the available main outlet elevation, distance to the lowest point to be drained in the field and requiring draining depths. The slope of open drains are designing to be more than at case of irrigation open channels for increasing the flow velocity to alleviate the growth of weeds. Take into consideration that flow velocity should be more in less drain capacity than bigger one, as shown in the enclosed figure. Figure showing synoptic diagram of main drainage collector and the branch drains. Look, my dear, an important table showing depths, lengths, bed slopes, and drainage coefficients of different types of open drains. Drainage coefficient. Really, it is the quantity or depth of water which should be disposed from an area on a day and consequently expressed as cubic meter per acre per day or millimeter per acre per day. It depends on different variables such as soil characteristics, irrigation method, climate, precipitation, crop species and its characteristics, field drainage depths and spaces, and required time for disposal of the excess water. Moreover, cross-section. Generally, open drains are designed by trapezoidal cross-section. The size of drain will vary gradually by the quantity of water to be disposed of. Depth. Normally, depth at all points along a collector should be sufficient to adequately draining the area. A minimum free-fall depth should be not less than 0.3 meter where tile drains outlet into an open drain. Moreover, side slope depends mainly on the soil texture and its stability and equal to horizontal distance divided by the vertical one as shown in the enclosed figure and table. Figure showing an elements of open drain cross-section. Table showing side slope for shallow and deep open drains under different soil types. Bed slope. Generally, bed slope of open drains are designed to be more than at case of irrigation open channel for increasing the flow velocity to alleviate more growth of weeds and sedimentation. Moreover, bottom widths can be computed for a given discharge after selecting grade, depth, and side slope by following the enclosed equation. Look, my dear, concerning pans, the excavated soil can be placed either on one side of dish as a level or on both its sides at case of using it as service road. Moreover, the maximum velocity occurs near the stream center and slightly 0.7 h below the surface and gradually decreasing towards the outer edges, and hence mean velocity can be defined on 0.6 depths at all cross-section of open ditches. Channel capacity. Really, open ditches should carry the required quantity of disposal water from the drainage area. After defining depths, bed slope, side slope, and bottom width and soil velocity should be calculated by using cheesy and manual equations. Really, there are an example of designing an open drainage branch collector to disposal an excessive water from a planted area has 15,000 acres by clay texture. Follow the solution steps, my dear. My dear, take care. Rest of solution steps: bed width, wetting area, wetting perimeter, hydraulic mean widths, roughness coefficient, velocity, and disposal quantity. My dear, the rest of solution steps until obtaining the suitable dimensions of drainage collector. Follow it, my dear, by yourself. It is so easy and clear. Curvature. Really, it is necessary sometimes to change the direction of main open ditches Hence, a gradual curve should be followed to decrease velocity and preventing any excessive erosion. Take into consideration that the radius of curvature depends on flow velocity and stability of side slope, as shown in the enclosed figure. Equations of calculation the dimensions of right curvature if needed. Moreover, junction of one ditch with another should be not allowed for occurring any of bank erosion, school holes, or sedimentation. Angle of joining is less important for channels having low velocity than which having higher velocity. Distance between ditches. Really, it is very important subject to calculation the suitable distance between drainage ditches. Take into consideration that flow of water in soil refer or acting in different gradient variables such as metric potential, osmotic potential, gravity potential, thermal potential, and hydrostatic potential. Great scientist Henry Darcy is the first researcher who studied and described the flow rate of water through soil and included that rate of flow inversely proportional with length of soil column, while directly proportional with both the hydrostatic potential differential and the cross-section of soil column, which is known as Darcy law. As explained in the equation in front of you, my dear, follow it really, it is so clear and easy. Look, my dear, soil hydraulic conductivity is affected by many variables such as soil characteristics and field properties, as shown in the enclosed table. Table showing classification of soil hydraulic conductivity and permeability classes. Look, my dear, Dolan and Hochhout studied the flow and disposal of excess water from soils at some assumption condition, which is known as Debit-Forchheimer assumption, as shown in front of you. Refer to those assumptions, my dear, because it is very important. Determination of soil hydraulic conductivity. Really, it is the simplest method for estimating the hydraulic conductivity by obtaining an undisturbed soil sample, and calculation of hydraulic conductivity can be done by measuring the collection volume of water Q which penetrated from the sample in a different time, as explained in the enclosed equation. Really, Fibert and Cow consider the auger hole method as the best field method for calculating the hydraulic conductivity inside other field conditions, as shown in the enclosed figure and equation. Figure showing determination of hydraulic conductivity by both auger hole and the piezometer method. Look, my dear, average value of hydraulic conductivity by auger hole method represents the horizontal conductivity of soil layer below water table in unlined cavity. On the other hand, piezometer method is based on measurement of flow in the lower end of lined hole with having a cavity space of 10 cm under the piezometer bottom, as shown in the enclosed figure and equation. Dolan equation. Indeed, he followed Debit-Forchheimer assumption conditions and concluded his equation, which depend on that the open ditches have an equal distance in between, parallel, have an vertical size, and lying on an impermeable layer, as shown in the enclosed figure and equation. Figure showing distance between open ditches according to Donan equation. My dear, follow the rest of calculation and substituting Donan equation. Out equation. Indeed, he follows the same assumption conditions of Tibet Forchmer also, and concluded his equation will depend on the same assumption of Donan, except that foundation of an impermeable layer should be at depth d from this back, as shown in the enclosed figure. Figure showing distance between open ditches according to Hoch-out equation. Look, my dear, the rest of calculation Hoch-out equation. My dear, as you see, the net result of Hoch-out equation is the same as Donan equation, as shown in front of you. My dear, an important example for calculation the distance between open ditches by using Hoch-out equation. Follow the input data and solution of example by yourself, my dear. So easy and clear. Drainage structure. Normally, drainage channels requiring a special structure to maintain the drainage water flow at the required level. There are different drainage structures such as culverts, siphons, and reinforced concrete lining procedures are necessary sometimes at curvature cases. Moreover, maintenance of open drainage ditches. Really, it is very important to begin maintenance of open drainage ditches after completing its construction directly. On this scope, knowing causes of failure and deterioration of open drainages are very important, as described, my dear. Follow it, it is so clear and easy. Look, my dear, preventive maintenance is cheaper than the continual maintenance, but periodical maintenance is the more economically one. Accordingly, and for these reasons, maintenance of open drainage ditches should be done and carried out by following the suitable procedures, as explains. Follow it, my dear. It is so easy and important. Goodbye, with my best wishes.